You're watching the last lesson on Pythagorean theorem. In this lesson, we'll be talking about the problems that you can run into that apply the Pythagorean theorem. So, in other words, we're going to talk about how the Pythagorean theorem is useful in real life scenarios or real life situations. So this video will talk about certain problems you'll see, and it can also be used to show how the Pythagorean theorem can be used to determine distance. So when we say we're going to apply the Pythagorean theorem, what do we mean? Basically, what we're saying is we're going to see how we can use this equation in realistic situations. It's also called word problems. And so these types of questions tend to give students a lot of trouble because they have to take the information from the question and basically solve it using the math we've talked about. And that can be quite challenging and difficult, especially when the problems can be so big. So I'm going to list out a couple steps that you can use to make the question a bit easier for you. So here's how you solve word problems effectively. Step 1. Understand. This is very key. Understand what the question is asking. Many times students know what the equations are, know how to solve the equations, know what they're doing, but they don't understand what the question was asking. And so they solve a question that the question didn't actually ask. And so they get an answer that isn't relevant to the question. So make sure you understand what the question is asking. The second part is find your useful information. Most questions will have a lot of filler. Most questions, word problems, they have a lot of parts in them that aren't important, right? So you can look at a question and if you need to, cross out what is not important. Step 3, if you can, model it. And by that I mean draw a picture of what you're solving. If you don't need to, it's totally fine. But if you can model it, it'll make it easier to solve. And then step 4, just apply the Pythagorean theorem or apply your knowledge. So let's take a look at an example. Steve is turning half of his backyard into a chicken pen. His backyard is a 24 meter by 45 meter rectangle. So his backyard is 24 meter by 45 meter rectangle. He wants to put a chicken wire fence that stretches diagonally from one corner to the opposite corner. How many meters of fencing will Steve need? So how do I solve this question? There's a lot of words in here. It's a big question. Okay, well, first off, I need to understand what the question is asking. The question is asking, well, how many meters of fencing will Steve need, right? How many meters does he need to make a chicken wire fence that stretches diagonally from one corner to the other? So once I understand what the question is asking, right, it's asking how many meters of fencing does Steve need? So note, the question is asking for meters, so the answer must be in meters, right? So I might trick you by giving you different units. I could say centimeters and then kilometers and then say give me the answer in meters. So please make sure you understand that the question in this case is asking for meters. So you give your answer in meters. Okay, so now that we understand what the question is, it's asking us, okay, how many meters of fencing does Steve need? Step 2, find your useful information, right? Steve is turning half of his backyard into a chicken pen. His backyard is 24 meters by 45 meters. It's a rectangle. He wants to put a chicken wire fence that stretches diagonally from one corner to the opposite corner. How many meters of fencing does he need? Well, the useful information here is we have a 24 meter by a 45 meter rectangle, right? 24 meter by 45 meter rectangle. And the wire fence stretches diagonally. The fence that we're making is stretching diagonally from one corner to the other corner. Now, this is all the useful information we need. This is significantly smaller than the actual question. I don't care if it's Steve. Who cares? It doesn't matter, right? We don't care he's turning half his backyard into a chicken pen. He could turn it into a zoo. It doesn't matter, right? It could be Charlotte turning her chicken pen into a zoo. It doesn't matter because that's not relevant to the question. So we can cut out a lot of useless information, right? We don't care about this. All we care about is we have a 24 meter by a 45 meter rectangle and we have a fence or a line that stretches diagonally from one corner to the other corner. So understand what the question is asking, step 1. Step 2, cut out the useless information. Find your useful stuff. In this case, the question is 47 words long. The words we used in order to solve the question, or in order to be able to solve the question, is 18. 62% of this entire question is not needed, right? So if you need to, you can rewrite the question. You can say, okay, 24 by 45 meter rectangle, wire fence diagonally from one opposite corner. What is that length? That's it. Okay, so now that I know that the question is basically asking a 24 by 45 meter rectangle, a wire fence stretches diagonally from one corner to the opposite corner, how many meters of fencing do we need? That's the question. We have a 24 by 45 meter rectangle. We have a wire fence, or even you can just say a line that stretches diagonally from one corner to the opposite corner. How much fencing do we need, or how long is that line? So, step 3, model it. Using what we know, we have a 24 meter by a 45 meter rectangle. A 24 meter by 45 meter rectangle right here, like this, right? 24 by 45 meter rectangle. That's it. And then the second part of the useful information is we have a fence that goes diagonally from one corner to the other corner. Okay. And the question is asking, from step 1, what we understand is how long is that fence? Or in this case, what is the length of this line? Right? So now that I modeled it, I have 45, 24, and x, right? I have this. What is x? Well, if you notice, this is making a right triangle, so I could model it like this. I could leave it like this, but if I want for clarification, I could write it like this. And so now I have a question just like we did in the previous lesson, where x is a missing part of our triangle, and I have 2 other sides. And I just need to solve it, just like we did in our other problems. So we apply our knowledge. We have a triangle. We have 45 meters, 24 meters, and we have x. Well, we have a squared, b squared, c squared. Classic Pythagorean theorem, right? Again, c squared represents the longest line, in this case, x, right? If x was here, if we're finding x here, then x wouldn't be the longest line, so it wouldn't be c. But here, x is the longest line, so x becomes c. Okay. Well, a, it doesn't matter which one's a. In this case, I'm going to make a 45, right? So I'm going to turn a into 45, so now I have 45 squared. I'm going to turn b into 24, so now I have 24 squared. And I turn c into x, so now I have x squared. So now I have 45 squared plus 24 squared equals x squared. Now, I'm not going to be that mean and make you do this by hand. These are large numbers, so you can use a calculator for these kinds of questions. What I'm looking for in these questions is, can you get the useful information? Can you solve the question using Pythagorean theorem? And can you find the useful information, right? Can you use it effectively? So we have 45 squared plus 24 squared equals x squared. Let's simplify it further. Well, 45 squared, if you use our calculator, becomes 2,025. 24 squared becomes 576. And x squared just stays x squared, right? So I'm just following this pattern. Okay, now I simplify even more. Now that I got rid of the squares here, I have 2,025 plus 576 equals x squared. Well, 2,601 is what this is. So these 2 numbers add up to this number. And now we have 2,601 equals x squared. Okay, so now we go back up here. I have x squared though. I want to get rid of that little 2. So remember, just like in normal algebra, we do the opposite. So if I'm squaring x, I need to do the opposite, which is square rooting. Whatever I do to this side, I must do to this side. So I square root 2,601, which will then become 51. The 2 disappears on this one, so I just get x. X equals 51. So Steve needs 51 meters of fencing. So here's a question you can do on your own and see if you can solve that one. To get to school, Sam needs to walk 400 meters south. He turns east and walks 600 meters. A bird that can fly over obstacles can fly in a straight line from Sam's house to the school. How far does the bird have to fly? right? So first off, you look at what the question is asking. What is the question asking? It's asking how far does the bird have to fly if it flies in a straight line? The second part is, what is my useful information? Well, I don't care that Sam gets to school, right? And it could be to work, it could be to the bus, it could be anywhere. I don't care if it's Sam, that's not important. What's important is he walks 400 meters south, then turns east and walks 600 meters. A bird flies over the obstacles and can fly in a straight line from Sam's house to the school, right? So 400 meters south, 600 meters east, and a bird flies in a straight line towards the school. So step 3, we model it, and then step 4, we solve. So try and do this one on your own. If you need any help, please ask. We'll solve this one in class as well. And then afterwards, practice these questions. Question 3, A, B, C. Question 4, 6, 8, 11, 12, and 14. Thank you for listening. This was a short lesson. It just focused on how to solve these word problems because these types of questions can trick a lot of students and they're not that hard if you break it down. Thank you for listening and see you next lesson.